Hello everyone. Now we are going to discuss on mathematical foundations needed for machine learning languages. So maths is very important concepts. So we will see what is the important topics maths in machine learning languages. So mathematical foundations, if you see, what we are going to cover is we are going to cover linear algebra, vectors, matrices, eigenvalues and eigenvectors, probability theory, statistics, calculus and optimization techniques. So first we will see linear algebra. So linear algebra, if you see, what is linear algebra basically deals with vectors, matrices, like that. So why linear algebra? Linear algebra, with the help of linear algebra, you can represent data. So you can represent data and you can use data in neural networks. You can use data in computer vision. You can use data in recommendation systems. You can use data in NLPs. So various applications are used with this linear algebra, like features represented, data transformations. So how the data is being transformed from one position to another position, and dimensional direction, deep learning computations. So now we will see examples of scalar, vector and matrix. Here you can see an example: single numerical value x is equal to 5. Okay, so x is equal to 5 is a single value. Vectors are collection of numbers. And one more thing is matrix is collections of vectors arranged in rows and columns. So I will repeat again. So scalar is a single numerical value. Vector is a collection of numbers. Matrix is a collection of vectors arranged in rows and columns. So if you see ML example, student data, age marks are given, 18 age and 85 is the mark, 19 age and 90 is the marks. So why vectors are important means vectors are having magnitude and directions. So it is represented in a column. So I can say student features can be represented in columns 18, 90, 85. Okay, so age is 18, attendance is 90 and marks are 85. And applications are feature representations, text embeddings, image representations. All are applications of these vectors. So next you see vector operations. We can do vector operations like 1.2 plus 3.4 is equal to 4.6. Similarly, scalar multiplication also you can do. So like 2 into 1.2 is 2 into 1 is 2, and 2 into 2 is 4. Then dot product. So dot product, if you see, 1.2 into 3.4. So how you will add 1.3 plus 2.4, it is 11. So the important is it is used, these vectors are used to measure the similarity between the data points. So mainly it is used in recommendation systems, search engines, natural language processing. And matrices. So introduction to matrices. So matrix we already saw. So matrix are used with rows and columns. So rows and columns. So 1, 2, 3 are rows, and this column is 1, 4, 2, 5, 3, 6 are columns. Why use matrices? So matrices, with the help of matrices, you can store data sets. You can store data in data sets. It is used in neural network weights. It is used in image representations, like that. And matrix operations, how you will do matrix operations? So matrix operations, what are matrix operation? You can do addition, you can perform multiplication, you can perform transpose, like that. So why these operations, where you can apply this operation is neural network computations, linear regressions, data transformations. And one more important thing is this eigenvalue. So the eigenvalue for a matrix, how you can calculate is eigenvalue for a matrix is A v is equal to A lambda, where lambda is the eigenvalue and V is the eigenvector. The main concept is eigenvector represent important directions, eigenvalue represents importance of the matrix. So what are the applications of eigenvalues? Like you can use in principal component analysis. So what is the use means? For example, you are having 1 terabytes of data. and in 1 terabytes of data you are having some 5000 features. So from the features you need only 60 features are important for your work to proceed. So how you can extract it? So how you can use it means with the help of principal component analysis, dimensionality reductions. So similarly the feature extraction you can use, and data compression you can use, and you can use what are the benefits is, so faster training, so reduced storage, so improved visualization. So all those things you can use this PCA. So probability theory. So probability is very important, where you can measure the concept of uncertainty. So if you are tossing a coin, getting head and tail. So what is the probability of getting head is 1 by 2, that is 0.5. Getting tail is 1 by 2. Again it is zero point 0.5. So probability, we can also have various applications are there in calculate using this probability theory. For example, by using the previous records. So yesterday the temperature was 40 degrees Celsius. What is the temperature after 4 days? So you can use humidity, moisture, and various features of the environment, and you can calculate if it is the temperature. You can the temperature after 4 days will be like you can predict. So it is used to this probability theory is widely applicable in predicting the uncertainties. Uncertainties. I can give one more example. Like people are doing medical diagnostics. So in medical diagnostics you want to as a doctor want to analyze whether by seeing the skin cancer, okay, skin cancer or skin diseases. So he can take photos of the images, and he can see whether this type, what type of skin disease it is. It is the general allergy or whatever, like that. So by seeing the images, people can tell people can predict their diseases. So all this disease prediction and all, this probability theory takes main parts, okay. So like one more thing in probability theory is conditional probability. In conditional probability, how we can say this condition probability is P of A given B, means probability of A event A given B. So the formula for probability of A given B is P of A intersection B by P of B. So here P of B. So for example, here this is the event of A, this is another event of B, and this is the A intersection B. Means A and B both are happened at the same time. So we given values are P of B is 0.65, P of A intersection B is 0.30. So what is P of A given B? So A given B is, we can apply this formula P of the probability of A intersection B 0.30 divided by 0.65, means probability of A given B is 0.46. 46 is a 46%. So we can say overlap. So A intersection is a overlap. A given B is a 46% of the time event A occurs given the event B has occurred. So means again we can say in simple words, if B has happened, there is about 46% of chance A had happened as well. Means we can say today B has happened. I can relate to you a real time example. B has happened means assume today it is raining. So B has happened, rained. Today it is rained, and there is about 46% of chance that it may rain after 1 hour. It may rain after 2 hours, like that. So in this way, using this conditional probability, you can calculate the probability of event occurs. And one more important topic is Bayes theorem. So in Bayes theorem, so you can calculate P of A given B is equal to P of B by A dot P of A by P of B. So what is this, all these terminologies? I will explain you one by one. So P of A by B. So it's a posterior probability. So posterior means probability of A given B. And P of B by A is likelihood, probability of B given A, likelihood of events. and P of B given not A is P of likelihood of not A, P of probability of B given not A, and prior probability P of A, P of B are prior probability. So probability of occurring A event occurring. P of B means probability of B event occurring, and total probability of B we can say P of B, overall probability. So this is here it is P of B is overall probability. So how you can calculate using this Bayes theorem is, so you can calculate P of B is equal to P of B given A dot P of B plus P of B given not A dot P of not A. So this is all the total of probability. So in simple words we can calculate P of A given B is equal to P of B given A dot P of A by P of B. So we can say P of A is equal to 0.68, P of B is equal to 0.25, and P of B is equal to 0.25. So finally, if we calculate P of B dot B given A, that P of A is equal to 0.17. So we can say 0.68. What does it mean? The probability of A given B is approximately 68%. So when converting into percentage, we can say it is a 68%. Means the observing B significantly increases the belief in A. So 68%. So if A occurred, then 68% of chances are there out of 100 that B will also occur. So you can make an analogy of either whatever application you are taking. So you have 68% applications. Based on that, like you want to go outside, so you can see whether it is raining or not. By using this analogy, you can develop your application. So these are simple examples where this maths is being used. And another mathematical concept is statistics. So statistics, you can say role in so summarizing the data, so understanding the recent trends, measure variability and draw conclusions. So there are various types are there: descriptive statistics and inferential statistics. So main things of statistics are mean, average values, so median, middle values, mode is most frequent values. So example I can say mean 10, 20, 30, 40 and 50. The mean value is the average values 30, and median is the center value. So after removing these two, means center is 30, and mode we don't have any mode value. And one more important formula you to understand is measures of dispersion with the help of variance. So how you can measure is sigma squared summation of x minus mu the whole squared by n. So it is used to apply in variability and outliers. So this formula is used to apply outliers. So what does mean by outlier? For example, 5 students are having some average marks, like we can say 60, 70, 80, 90, something like that. But one student is telling he is having mark 200. So just imagine, it won't happen, but it is happening. He is having mark of 200, then this is the outlier. So when out of 100, we can say the normal marks are like 65, 75, 85, 90 like that. But a student is having a mark of 180, like that means it is an outlier. Okay. Similarly, this is an overfitting. And similarly, underfitting means a student is telling he is having mark of -5, -10, means this is underfitting. Like that. So this is like this is very very important concepts in maths you need to understand. And data distribution, here you can see it, bell shaped curve. So this is a symmetric property, means whatever distribution is here, this same distribution is also here. And it is also using the formula for mean, median and mode. So here for you can say, so 0 to 49, so 0 to 49, 50 to 16, we can say a calculation of marks of a student in a classroom. So if it is properly distributed, you are getting a bell curve, then it is okay, it is properly distributed. Or else if it is an hike or if it is a declination, means we have to analyze it carefully. It should not be like declined or inclined. it should be properly analyzed. And what is the role of calculus in machine learning? Calculus is provided how to find best possible solutions. So it is used to measure change, optimize the models, training the neural networks, and gradient, like we are having various gradient descents are there, like helps to find the slope of the loss function to update parameters and minimize the error. Back propagation, it is used to calculate chain rules, efficiently compute and gradients in neural networks. And optimization also used to identify minima or maximum of the values. And derivatives, it is used to understand change, power of intelligence. It is used for derivative measures rate of change. So mathematical foundations are dy by dx. So examples are d of distance by d of time. Is to find optimal parameters by minimizing the loss functions. And then if you see optimization means like it is usually you will be initializing the parameters, it will compute the loss and it will calculate the gradients. Okay, after calculating the gradients, if any loss occur, then it will update the parameters, and finally this action will repeat until you are finding better parameters and better predictions and better high performance values. And examples like are like gradient descent. So gradient descent, like theta is the function. So here in theta is equal to theta minus n uh, j theta. Like here model parameters are there and learning rate is given and loss function is given. So using this you can say gradient descent, stochastic gradient descent, or mini batch gradient descent. So it is used in various applications like linear regression, logistic regression, deep neural networks. And finally what we saw is like linear algebra, vectors, matrices, eigenvalues, probability theory, Bayes theorem, statistics, calculus, optimization, and gradient descent functions. I hope you understand basics of mathematical concepts which are useful in machine learning algorithms. So these are these basics. You can explore more based on the applications which you are using, which you are applying in machine learning algorithms. So soon we will meet with our next concept. Okay, happy learning. Thank you.